Okay, I'm going to briefly go over how you calculate pulse wave velocity from a blood pressure signal and an ECG in PWRlab. It's pretty simple to do, and what we'll do today is I'll show you how we set up the data pad, how we set up the chart window and the parameters we want to measure, and then how we bring this into Excel and just quickly calculate one example of pulse wave velocity. So in this window we have an ECG and a tonometer signal. And in the channel settings, we can add a couple of channels in, and I've already done that here, called the filter of the tonometer, and in this case it's the second derivative of the tonometer. To do that, I just add 2 channels, so instead of it being originally 6, I've changed this to 8. And in here, I click on one of these, go from no calculation to a digital filter. I choose the source of the information, which would be the tonometer signal. I select the type of filter that I want to use, in this case a band pass, and I select these specific high cutoff and low cutoff frequencies of 30 and 5 Hertz. In the derivative channel, I want to get the second derivative of the tonometer, so I click on the tonometer channel from the pull down menu. I select a whole number of points, about 151 should be enough points to determine the derivative, and then take that information and plug it into my channel 8. I want it to be the second derivative, so from the pull down menu here I pick the second derivative. So what that'll do is create 2 different channels, which you can already see here, but if you can't see these channels originally in your file, as soon as you do these steps they'll appear and you'll have the relevant information for those channels, and then we can subsequently calculate pulse wave velocity. So to do pulse wave velocity, there's a macro built in, which is a little series of steps that I've told the computer to do a number of times. It's already built into every single one of the files that we've collected. In order to use that macro, you click somewhere where you have good signal, so about 20 beats of good blood pressure waveforms. You click in any of the channels, and then you run that macro. And what you'll see once I run this macro is that it will highlight each beat and dump information into the data pad. Now, the information we want in the data pad depends on what we want to find out. So particularly what we want to find out is how long it takes for a pulse wave, this one here, to get from the ECG all the way to here. So what we want to do is find similar parts on all these waves that we know are reproducible, and find the time delay or the time difference between the spike of the ECG and, let's say, the foot of the pulse wave. So if you notice, the cursor on channel 1 is slightly to the right of the adjacent ECG channel, and that time delay will be what you're going to use for the denominator of your pulse wave velocity equation, which is distance divided by time. So let's just highlight one beat and go over what it actually will look like. So the computer is going to go along and locate this spike. It'll put a marker on the spike to find out what time the ECG was at its peak. It'll then move forward and highlight till the next peak, which we can't see in this particular window, and then we can dump information between those 2 points about these signals into the data pad. Specifically on channel 7, which is the filtered information, we're going to ask or create a column in the data pad that tells us at what time during that highlighted area does this minimum point actually happen. And you can see just in the zoom window function up here a delta time, which is from the marker which I placed on the top of the ECG spike all the way to the bottom point of this particular channel point is about 209 milliseconds. That 209 happens to occur where the foot of the pulse wave is, and that's what we'll use, that 209 milliseconds, as our pulse transit time, which is the denominator for our pulse wave velocity equation. So without further ado, I'll just run the macro from this time point here. So go into macro, and you'll see it now highlight 20 beats and dump information into the data pad. I'm just going to clear the data pad for a moment so that you can see exactly what it drops in there. And what I have done in the data pad is added a column that is based on the idea that we want to find the time at minimum value in the filtered tonometer signal from the general statistics menu. So you'll have to set that up. To set that up, you just simply click on this column, click on general statistics, time at minimum, and then click on filtered flow from the pull down menu. So that's the channel we're getting the information from, and click OK, and that will add this channel into your data pad. So going back, finally we're going to run this. So if I hit macro, carotid 20, it goes across, highlights every beat, and dumps information into the data pad, as you can see here. If I highlight this information and copy it and go into Excel, I can calculate pulse wave velocity. So to do that, I'll just dump this in here, take this information and add it up here to the top, and then take the information from here, it was a problem, so I'll just do that one more time. Click here, get rid of the marker, because everything is relative to the marker right now. I go back into Datapad and recalculate those values. Click OK. There we go. Fixed everything. Go into Excel, paste it in again. Right. So the selection start we want is here. So the time where there's a maximum value on the ECG. Dump that in this column. And then the point of time when you see the minimum in that filtered tonometer signal is here. Now if we calculate the time difference between this and this, you'll notice that this one occurs a little bit later than this one. And the time difference is actually here, and you can see the equation at the top, which is C2 minus B2 gives us the pulse transit time. I can calculate that out for every single beat by dragging here and get an average pulse transit time, or time delay between the ECG and the foot of the pressure wave. This can be done for any pressure wave, either in the carotid, femoral, or in the radial artery. And if you know the distance, either between the ECG and the wrist, or say the ECG and the femoral artery or the foot, you can plug it in here and then calculate out pulse wave velocity using this equation here, which is distance divided by time. Now you can clean all this up. Oops. And essentially now you've calculated pulse wave velocity for that particular person using 20 average values. So that pretty much concludes that little tutorial on how to do pulse transit times. There is one caveat that you should all know, and it is that this ECG signal arrives at the PWRlab 35 milliseconds faster than the signal being sent from the SphygmaCore device to the PWRlab does. And so there is a bit of a correction that has to be made in our data in order to make sure it's valid. So to do that, we're going to adjust our pulse transit times just a bit for this time delay. And to do that, we'll say, I've already determined that the time delay is 35 milliseconds, so if I say equals, one column down, equals this minus 0.035 milliseconds, we get a corrected pulse transit time. And if we just highlight these values and drag them over one, we should see the, and if we make sure that that stays the same, we should see the corrected pulse transit time, which is 3.1 rather than 2.6 meters per second. So that's it for that tutorial. Hopefully you guys can get started on your data. If you can't, you know where to find me. Thanks a lot.